So last class period, I introduced this idea of a differential equation. And all a differential equation is, it's something that starts off, it says dy dx equals, let's say, x squared. Your job is, let's figure out what y is. And so if dy dx, so if the derivative is equal to x squared, then y is going to equal x cubed over 3 plus some sort of constant. And, we could come up with our equation. Just we figure, like when you're solving a differential equation, your job is, what does y equal? So if dy dx equals this, then y equals this part. And then we can figure out what y is. Last class period, when we talked about slope fields, we were talking about situations where we couldn't figure out exactly what y equals, but with slope fields, we could figure out what a picture of y looks like. Well, today we're going to talk about, well, what does y equal? And so I'm going to start with, a differential equation. So here's our differential equation. So I want everybody to write down. And even if you're not big on taking notes, we're only going to do a handful of examples. You need to write all of these down. I'm going to walk through these. So we're going to start off, and this is dy dx is equal to x squared over y squared. I'm going to need more space than this page has, so I'm just going to start here. So here's a differential equation. How do we know it's a differential equation? Well, derivative equals stuff. And just to make sure we understand, the goal of solving a differential equation is, at the very last step is going to be y equals something, and we have to know what y equals. So if the derivative equals something, right, then how do we get y by itself? And today we're going to talk about separable differential equations, right? This thing. So why is it called separable differential equations? Because you can separate the variables. And here's how it's going to work. And this is actually how all of these are going to work. When you separate the variables, what's going to happen is, on the left-hand side, you're going to get a left-hand side and a right-hand side of the equal sign, and the y's are always going to go on the left, and the x's are always going to go on the right. We're going to separate our variables, and when you separate the variables, the y's always go on the left, and the x's always go on the right, and I'll explain why in a little bit as we do this problem. All right, so step 1 in our differential equation, separate the variables. Y is on the left, x is on the right, and keep in mind is this dy is a y and this dx is an x. So to get my y's on the left and the x's on the right, effectively, I'm going to cross multiply. So this is going to give me y squared dy equals x squared dx. Give everybody, again, you should be writing this down. All right, so we've separated our variables. Notice the y's are on the left, the x's on the right. Now we've got to get rid of this, this dy and dx, and how we do that is we take the integral of both sides. So we take the integral of this side. That's not so bad. That's just going to give us y cubed over 3 plus some sort of constant. And I integrate this side. That's going to give me x cubed over 3 plus a different constant. Now in practice, we're not going to write the two constants after this example, but right now, anytime you take the integral, you got some constant. Take this integral, you get this other constant. Now, so step 1 is get rid of the dy and dx's, which we've done. We've gotten rid of the dy dx's, but we're not finished, because at the end of the day, I better get y equals something. All right, so now let's talk about these constants. Well, I don't like this constant over here, so I'm going to subtract this constant from this side, and whatever I do this, I'm going to subtract this constant. And then I'm going to say a phrase that you're going to hear frequently today. This constant is a number you don't know, and this constant is a number I don't know. And so if I have a number I don't know minus another number I don't know, what we end up with is basically just one number I don't know. I still have my x cubed over 3, and I have my y cubed over 3. So basically from this point forward, whenever you integrate both sides, you only have to put the plus c on one side, and you're going to put it on the right. this is going to make our life a lot easier as far as computations go. Technically, you get two constants, but when you combine two numbers you don't know, you basically just get one number you don't know, and so that's what I have. All right, we're not done. I need y by itself. So to get y by itself, well, I guess I'm going to multiply everything times 3, right? Because that's what we're going to get y by itself. And so when I distribute the 3, that's going to give me y cubed is equal to x cubed plus, here's this little phrase again. C is a number I don't know. And when I multiply it by 3, I still get a number I don't know. So it turns out 3 times a number I don't know is just a number I don't know. It happens to be a bigger number that I don't know, but it's a number I don't know. Which is fine, right? I'm getting closer. I still don't have y by itself. To get y by itself, I'm going to take the cubed root of both sides. And so then I finally get y is equal to the cubed root of x cubed plus c. And that's my answer. This is called the general solution. Why is it called the general solution? Well, because we don't know what c is. We are gonna talk about the particular solutions. That's the next example. But when you are solving a differential equation, the two things you're going to be asked for are what's the general solution or what's the particular solution. As far as your general solution, it's got a c. Particular solution, you have to figure out what c is, and they'll give you enough information. But let's go through the procedure. As far as separable differential equations, you've got a differential equation. You're going to separate your variables, and the y's are always on the left, the x's are always on the right. Then you take the integral of both sides. Remember to put the plus c. That's actually a really big deal. Pretty much I'd like to say every year, but at least every other year, there's a free response question that requires you to solve a separable differential equation. Free response question is typically free response question that's worth 9 points. Solving this procedure of actually solving the differential equation is usually worth 5 points. If you forget to put the plus c, you lose 3 or 4 of those points. So, and we'll see some examples of that tomorrow and Wednesday. But remember to put the plus c, then do some algebra to get y by itself, and we've got our general solution. So, there's our first example. And why is it always going to be y's on the left and the x's on the right? Okay, if you fade it out, I need you to come back in for this one little part. When you are separating variables, the dy or the dx, neither of those can be in the denominator. You can't handle it. There is no technique of taking an integral that handles a d something on the bottom. So if you have dy over dx, if you got the dy's on top here, I need this dx to be on top, so that's why it has to go over on this part. And so you're always going to have a dy on the left, you're always going to have a dx on the right, which means all of our y's are going to be on the left and all of our x's are going to be on the right. I mean, you can have fractions, but you've got the dy is always going to be on the left and the dx is always going to be on the right, because every single problem I give you, or the AP exam gives you, is going to be dy dx equals this. All right? Now, I do like the calculus maximus examples, except he tends to get a little. I want a more basic one before we start. Do his next one. So, next differential equation. Just an example. I'll say that y prime is equal to y over x. No, whoops, sorry. We'll do x over y. The y over x will be a little bit later. All right. Now, this is a differential equation. The derivative equals this. So, anytime you see y prime, and the AP exam will give you y prime, sometimes they give you dy dx, sometimes they give you y prime, you have to know when you see y prime, you write that as dy over dx equals x over y. And now, here's our separable differential equation. We're going to separate the variables. I want the y's on the left, I want the x's on the right. So this is going to give me y dy is equal to x dx. I've separated my variables. Now I'm going to take the integral of both sides. So I end up with y squared over 2 equals x squared over 2 plus some constant. Again, notice you have to put the plus c. Don't put it on both sides now. I just did that the first time. This is a number you don't know. We combined them. We basically combine all the numbers we don't know over here. Now we're not done. We've got to get y by itself. So multiply everything by 2. So end up with y squared equal to x squared plus, and this is where you kind of get in the habit of 2 times a number you don't know is still a number you don't know. Now to solve this, we're going to take the square root of both sides. And oddly enough, normally you just take the square root of both sides, and some teachers say, yeah, you got to put the plus or minus because it's not that big of a deal. It's just kind of we do it. When solving differential equations and you take the square root of both sides, you got to put the plus or minus. And I'm going to get into probably, not today, but I am going to get into later why you have to have the plus or minus. Because if you don't have the plus or minus, you're going to miss a question. It's very easy to miss. But here we have solved our general, we have solved our differential equation, meaning we had derivative equals something. We've got y by itself, and once we actually figure out what y equals, we have now solved our differential equation. All right. So now we're ready for example 2. And you need to write this one down. So if you got the page, great. If not, go ahead and write our differential equation down. So that's dy dx is equal to x squared y. And now if we look at the instructions, it says find the general and the particular solutions. So the first thing we're going to do is we're actually going to find the general solution, which means our answer is going to have a C. And then to find the particular solutions, they give us these conditions of, like on last class period, if we had a slope field, we would have our initial condition. That would be where we place our ping pong ball, and the slope field would blow the ball around, and we could figure out what y looks like. Now we're actually going to use our initial conditions to help figure out what that C is. But enough of me talking, we need to solve. So, step 1, separate the variables. I want the y's on the left, I want the x's on the right. So, let's see, to get the y on, I'm going to multiply both sides by dx. Right? So I end up with dy is equal to x squared y dx. I got to get rid of that y. So I'll divide by y. So now I'm looking at dy over y is equal to x squared dx. I got my y's on the left, I got my x's on the right. Right? Once I've separated the variables, now I'm ready to integrate both sides. And so when I integrate this side, well, that works out nice. That just gives me x cubed over 3. And I'll go ahead and put my plus c on this side. And now we have this thing. And this is a pretty frequent event when solving separable differential equations on the AP exam. Doesn't always happen, but I'm going to say 60 to 70% of the time this shows up. And so this is where it's very important that you remember that when you take this integral, you've got to remember that this is equal to natural log of y. So one of those things, right? When you take, if you see dy over y, when you take the integral, you've got to know that's natural log of y. So great, I have now, I have gotten rid of the dy and the dx, but I still need to get y by itself. And how we get y by itself, we got to get rid of the log. And so that's where I call it the swoop principle. Remember, natural log is log base e. And so when I swoop, this moves over and all of this becomes the exponent. And so when I swoop the e over, that's going to give me y is equal to e. And that big old mess is my exponent, which is x cubed over 3 plus c. I'm going to pause to make sure everybody's writing this down. That's a big deal. It's not hard, but if you don't write it down, you're going to forget it. Okay? And you might think we're done because we got y by itself. Unfortunately, we're not. There's a little more algebra we have to do. And that little more algebra we have to do is dealing with this exponent. So before we deal with this exponent, I want to review some properties of exponents. Are we okay that e to the x times e to the y is equal to e to the x plus y? Right? I mean, if you don't like that, you could say like e squared times e cubed is equal to e to the fifth. But in general, when you multiply the bases and the bases are the same, you add the exponents. Well, actually, I don't care about this direction. What I care about is this direction. Meaning, if you have e to the something plus something, that's equal to e to the something times e to the something. So that means e to the x cubed over 3 plus c is equal to e to the x cubed over 3 times e to the c. Very, very common thing to do when dealing with differential equations. Incredibly common. When you see this, you got to break it apart. And then I get to ask my famous, or not famous, but the phrase that I like to say a lot when teaching this. C is a number I don't know. E to a number I don't know is just a bigger number I don't know. So technically this is e to the x cubed over 3 times a big number I don't know. In practice, we usually write that number in front. And so this is equal to c e, let me scoot this down just so I get confused, c e to the x cubed over 3 and so this is my general solution, right? General solutions don't always have a plus c. There's an example where your c is actually being multiplied, but this is the general solution. Now, I want to deal as far as the particular solution goes. All right. They give us some information. The first piece of information they give us, they said f of 0 is equal to 1. So if I have f of 0 is equal to 1, they're telling us when you plug in 0 for x, you better get 1 for y. So if I plug in, I get 1 for y equals c e to the 0 cubed over 3. Let's see, that's 0. E to the 0 is 1. Okay, so c is equal to 1. So if this is your initial condition, c is 1, then my particular solution is going to be y is equal to 1 e to the x cubed over 3. The other particular solution, they tell us that f of 0 is equal to negative 2. And so this is saying when you plug in 0, you better get negative 2. So using my general solution, here's negative 2 is equal to c e to the, well, that ends up just being 0 because 0 cubed over 3 is still 0, and which is a big fat 1, and so I now know that c equals negative 2. So my particular solution in this case is y is equal to negative 2e to the x cubed over 3. And this type of problem, very, very, very common, particularly on the free response questions. I pretty much think every year they have a free response question that looks like this. I mean, in more recent years they make them a little trickier, but for the most part, you've got something like this. All right. I have one of my examples as opposed to one of the Calculus Maximus examples. So other wording they've got. What if I tell you the change pages? What if I tell you the slope? If I tell you the slope of the function is equal to y over x squared, and it passes through the point 1, 3. So they wanted to, find a function whose slope is defined by this, and it passes at the point 1, 3. Well, if they ever tell you slope, that's just another way of saying that's your derivative. So they're giving you a differential equation. So they're telling you your derivative is y over x squared. And now we've got, now our job is to solve for y. So we have to separate the variables. So that means I want all the y's on the left, all the x's on the right. And let's see, I'll put the y down here. So it's going to give me dy over y is equal to dx over x squared. And hopefully you get pretty comfortable, like when you see this, it's like, okay, I got to move stuff so I get y's on the left, x's on the right. Now we take the integral of both sides, and I'm hoping you recognize this as, that's going to be that natural log of y. And that, you might want to write that as x to the negative 2. So that's going to give me x to the negative 1 over negative 1 plus some constant. I'll go ahead and write it. That's going to give me natural log of y is equal to, I'll clean that up, negative 1 over x plus some constant. Again, should be writing these out. I think I've got 2 more examples, but the more you can write these out, the easier it's going to be for you later on. Next, I got to get y by itself, so to get rid of the natural log, I'm going to swoop. End up with y is equal to e to that mess, which is negative 1 over x plus c. And we're going to do the same trick. So this is e to the negative 1 over x times e to the c. And e to a number you don't know is just one big number I don't know. And when we write that in front, we end up with, this is c e to the negative 1 over x. So I'm looking at y is equal to c e to the negative 1 over x. So here is our general solution. Now to find if it says it passes through a point, they're telling you when you plug this in for x, you better get that out for y. So they're giving us information so that we can find out, what c is, so we plug it in. We plug in a 3 for the y, c, e, and I plug in a 1 for that. Well, it's negative 1 over 1, so I get a negative 1. And now we have to solve for c. Sometimes they ask questions because you just, sometimes they make c a little more challenging to figure out. And let's see, that's really 3 equals c over e, which means c is equal to 3e. So I had to do a little more work to figure out what c is. That's not really the mean part of this problem. The mean part of this problem is when I write it down, I get y equals 3e, because that's the c. And then I have the e to the negative 1 over x. And if this was a multiple choice question, this wouldn't be your answer. The reason it wouldn't be your answer is this is e to the first and this is e to the negative 1 over x. Whenever you multiply the bases together, you get to add exponents. And so this is y is equal to 3e, and when I add the exponents, I end up with 1 minus 1 over x. Which seems kind of mean, but unfortunately I've seen it, like on the AP exam. It's one thing to see it in a textbook, it's another when, yeah, they actually expect you to know how to do this. All right. So now let's look at a little more challenging problem. Let's write down dy dx equals xy squared plus x. All right, so what do? Right, we got to separate the variables, right? I know I want y's on the left and I want x's on the right, but this mess is, a little confusing. Well, you got to do a little bit of algebra. If you look at this, you can factor out an x, so we end up with dy over dx. When I factor out an x, that's going to give me y squared plus 1. So anytime you see like a pile of stuff, see if you can factor. And now when you look at it, I think it's a little more obvious how we can get our y's on the left and our x's on the right. To get my y's on the left, I'm going to take this, I got to divide by that y squared plus 1, and I'm going to multiply by dx, and end up with dy over y squared plus 1 is equal to x dx. And if you want to, you can multiply both sides by dx and then divide by the y squared plus 1. But your job is, I need all the y's on the left, all the x's on the right. Now that I've separated my variables, now I can take the integral. Well, this side isn't so bad. Well, it's just going to give me x squared over 2 plus some constant. But this side, now this is where, like what we taught, I know it's been over spring break. This is where you've got to know your integrals or else you just can't answer the question. So when you look at this, I'm hoping some of you recognize that this is going to be arctangent. So after my integral, I have arctangent y is equal to x squared over 2 plus c. But I'm not done, because when you're solving a differential equation, you need y by itself. So to get y by itself, we got to cancel out the arctangent. So we're going to have to take tangent of both sides. And that tangent cancels out arctangent, so I'm left with y is equal to tangent of x squared over 2 plus c. Now, this is actually very similar to a free response question from 2 years ago. Not identical, but pretty darn close. And if you didn't remember this was arctangent, you couldn't get the points. I think you could. It is kind of funny when we actually start looking at the rubrics when they grade it. Usually you get 1 point for separating the variables, you get 1 point for taking an integral, and the remaining 3 or 4 points hinges on the fact if you remember to put the plus c or not. If you forget to put the plus c, then you don't get, that's like you lose 3, sometimes 4 points. But we've solved an equation of, now, there is an interesting problem. And it has to do, I do want to sort of end today with population growth. So population growth, like if you think about how bacteria multiplies, or insects multiply or whatever. The rate that they change depends on what the current population is. Like, for example, let's say if I only have 5 flies in my house, they're not going to their rate of change is not going to be very high. But if somehow I messed up and I have 30 flies, the rate that the number of flies is reproducing is a whole lot greater. And so we officially say that by saying the rate of change of whatever the object is proportional to the quantity itself. So it's proportional to how much stuff you have. Translation of, and they've got this nice little differential equation. They're saying the rate that y is changing is proportional, means it's got some constant of proportionality. That's just a number. We don't know what it is proportional to the amount of stuff you have. And this is it's actually population growth and decay the way it works. But the way I always think about it is the more bacteria have, the greater rate that the bacteria is multiplying. Slightly different. I mean, notice we're using a dt because it's doing with respect to time. Basically, treat that as an x. This is some sort of constant. It's just a number. If it makes you feel better, you can put a 7 there, but I just think it's a number. But this is a differential equation. And in this case, so the way I solve this differential equation is I want the y's on the left and the t's on the right. The k, we're going to leave here, and I'll explain why in just a second. So I'm going to move the y down here and put the dt over here. So I end up with dy over y is equal to k dt. I guess technically you could put the k in the bottom, but generally I don't like dealing with fractions if I don't have to. I would much rather deal with this number right here, where it's not a fraction. All right, I've separated my variables. Now I'm going to take the integral of both sides. Oh, look, there's that dy over y. So hopefully we're recognizing that that's going to give us natural log of y. When I integrate k with respect to t, this is going to create a t. So this is going to give me kt. And yeah, so that, remember, that's just a number. So like if you integrated 7 dx, you would get 7x. So if I entered, 7t, I would get 7t, or this is kt. Well, I'm not done. I've got to get y by itself, so I'm going to swoop. So I'm going to swoop this over. That's going to give me y is equal to e to the kt. Oh, whoops, I forgot. I would have lost points. Gotta remember to put that plus c. Which gives me a plus c on this side. And so now we get to write this as e to the kt times e to a number I don't know. Well, e to a number I don't know is, this whole thing is just a number I don't know. And when I write it in front, that gives me c e to the kt is equal to y. Okay. So why am I talking about this? Well, I don't know if you remember this, but in Algebra 2, I think it was the last time, did you ever see this formula? It was A equals PE to the RT. This little formula was for compounding interest continuously, but he tended to use it for exponential growth and decay. Well, that formula is this formula, except, there's your P, there's your R, and there's your T. And I always like, when I first start talking about differential equations, is this gives me a chance to explain where that formula comes from, or another way to derive it. There's a clever way to do it in Algebra 2, but I never really liked it. I like this way significantly better. One last thing. I'm not going to do another problem. I just want to kind of warn you on this. In dealing with, let's say I gave you x squared plus 3y dy dx is equal to 0. Say you were given a problem like this and you're saying separate the variables. You think, I haven't shown you how to deal with that. Like you said, I want the y's on the left and the x's on the right. Well, I guess I have shown you how to deal with it. Okay, I got most of the y's on the left. So if I move this x over, that's going to give me 3y dy dx is equal to a negative x squared. And then I guess all I have to do is multiply both sides by dx, so I end up with 3y dy is equal to negative x squared dx. Right. You still want to, no matter what you're given, make sure you get all the y's on the left and the x's on the right.